Hello again, geometry students. Today we're working on section 9.2, which is all about reflections. The learning target is I can perform a rigid motion reflection given a rule and a pre-image. Take a minute to pause and write that down if you are taking notes. Okay, so our warm-up and review today is all about graphing vertical and horizontal lines because you're actually going to need these quite a bit in your homework and in the notes today. We haven't done a whole lot of this year, and so in case you're kind of forgetting, like, how do we graph lines that don't exactly look like y equals mx plus b, there are two videos that I posted in the comments or in the section description box, I guess, below. So you might want to take a minute to watch those if you don't remember how to do this before you take a minute to try it. Once you've watched those videos, come back and take a minute to try out your do now or your warm up, and then I'll go over them. So I would pause here and then come back to it in just a minute. So our first line is y equals 2. So if you look over at our graph, we want to look right here where the y value is 2, and then we're basically just going to go out on either side from where y is equal to 2. So that means I'm going to be graphing a horizontal line. So here's my line at y equals 2. I think what people think when they look at a line that has a y in it is they think, oh, it looks like the y-axis, so it must go up and down like the y-axis. It's actually flip-flopped. So if it goes through y equals 2, that means it has to go through that point perpendicularly. And you can watch those videos. There's a couple nice videos where, or one of the videos goes through and actually graphs the points and shows that the y value is always 2, but the x value is always changing, which means that y is going to always stay the same, but x could be anything. So for the next one, x equals -1, same deal, right? So we're looking at where x is equal to -1. Okay, and then we want x never to change from being -1. So anywhere I put my laser pointer, I always want it to be like really on that -1 line for x, which means that we're actually referring to a vertical line that goes up and down through the point x equals -1. For x equals 0, if x is equal to 0 and we want x to always stay 0, I can't go over to -1, I can't go over to +1. I have to actually just stay kind of vertically through that x equals 0, which means when I say that x is equal to 0, that's actually just the y-axis. And similarly, if I said that I wanted to find y equals 0, that would actually be the x-axis. Fun fact. If y is equal to -3, I'm looking at -3 on the y-axis right there, and I want to draw a line that goes right through that point. So I'm going to draw my line here. There we go. And there's y equals -3. So just a little bit of a warm up and review. If you need some extra help with that, let me know and I can maybe send you some extra resources and videos. But this is kind of something that you should have known from algebra last year that's going to be very foundational for our notes today. So definitions real quick before we get into the actual examples. We're talking about reflections today, which if you remember from our notes during translations, a reflection is a transformation that flips an image across a given line. And I like to think of this as it's a reflection like in the mirror, right? If I hold a mirror up to myself, I'm basically going to have a flipped version of myself on the other side. So an interesting thing about reflections is that the pre-image and the image are always going to be equidistant from the line of reflection, or an equal distance, right? So think if I look at myself in a mirror, and this is hard because I'm actually doing this in the screen right here, it's a mirror for me. If I look at myself in the mirror, the reflection of my face on the other side of the mirror, let's say I'm about 6 inches away from my hand or my mirror here, what it's going to look like on the other side of the mirror, if you can see, is that my nose would be 6 inches on the other side of the mirror, which obviously it's not, it's just on the mirror, but it should always look like if it's, if it's 6 inches away on one side, it's going to be 6 inches away in the flipped version, okay? So I'll show you more about what I mean by that in just a minute. So pause if you need to write this definition down. So some notation for reflections. Very similar to our notation for translations that we learned about yesterday. The capital R just means that it's a reflection. And by the way, you might see like in the Khan Academy video that I'm going to post just as kind of some supplementary information for you guys today. Sometimes mathematicians will sort of forgo having this equals a prime part, and sometimes they'll just put R and whatever. Sometimes they won't even put these parentheses here. Sometimes they'll just say R with the line, or if it was a transformation, they might say, or sorry, a translation, they might say T and just the XY right here. So this is kind of like the full notation. A lot of the time you're going to see mathematicians be kind of like mathematically lazy and just show the very beginning of this notation. When I say the line, it really means which line to reflect over. So you're never actually going to see it say line right here. You're usually going to see it saying something like x equals 1 or reflect across the y-axis or something. So that's actually going to be like an equation of a line right there, usually. And we're always going to be doing horizontal and vertical lines for our purposes, but you could reflect across a y equals mx plus b line too. It's just a little bit more complicated. Obviously from yesterday, A and A prime are the pre-image and the image, so the starting point and then the final reflected image. Okay? But again, as I mentioned earlier, sometimes mathematicians will leave off. So in example 1, it asks us what it means by the capital R, x-axis, and xy. So this is what I mean by sometimes mathematicians are just going to leave off the whole pre-image and image deal and just say the reflection, the x-axis, and the little xy point. So because of the capital R that's at the beginning, that means we're going to reflect. And then the XY, that's our pre-image, right? So it's telling us that we're going to take every XY point and reflect it over the x-axis. So see how right here, I'm not going to say line. I'm going to say what line I actually want to reflect over. So for example 2, I would recommend you kind of sketch this graph out on your paper and do it along with me and maybe actually pause the PowerPoint and try it, maybe see 1 or 2 of the points and then try the last 3 while you're watching, or pause it and then check your answers with my PowerPoint to kind of get some practice. So the first question asks us to reflect point A over the x-axis. So I'm going to ignore all of the other points that are on there and really now just focus in on this point A that's right here. Okay, so I'm focusing on point A. I see that this, the directions or kind of the rule that's up here tells me to reflect across the x-axis. So my x-axis is down here. It's this horizontal line. I don't really have to graph anything. I'm just going to highlight over that x-axis. So then I want to think about this as if I'm folding a piece of paper. So if I have a piece of paper that's a flat piece of paper like this, I want to fold it across the x-axis so that I've basically just folded it in half, right? So I have my piece of paper here. I fold it in half. If I fold it in half, my A point is going to end up, see how right now it's 1, 2, 3 points away from the line? If I folded it in half, it would end up 1, 2, 3 points away in the opposite direction, right? So I tend to really always think about this as if I folded this graph in half, where would my new point end up? So if I graph that point, that's actually going to be my A prime point when I reflect it over the x-axis. And when I have that little equal sign up there, that means just what are the coordinates of the new point. So this A prime point that's down here, the coordinates are -2 for x and -3 for y. And so that's what we would write for the equals part there. Number 2 asks you to reflect point B over the y-axis. So again, I'm going to ignore everything else because this number 2 clearly tells me I'm just trying to look at point B as my pre-image. So here's point B right here. I'm going to draw the y-axis in, or just in this case kind of highlight it because it's already on my graph. So I'm highlighting my y-axis in yellow right here. Okay. If I'm going to reflect B across the y-axis, if I think about if I folded this piece of paper in half vertically, right, across the y-axis, if my point B is right here, when I fold it across, it's going to end up the same distance. Remember that word equidistant or equidistant we said? So point B is going to be equidistant on one side as it is to its image on the other side. So when I graph point B prime, if it's 2 away on the right over here, when I reflect it across, it's going to be 2 across on the left. And then that new point is -2 on the x-axis and +4 on the y-axis. It gets a little bit hazy here because we're going to start graphing all 3 of these other points. So I'm actually going to erase my A prime and B prime and go one by one for the next few so it doesn't get too complicated. I would encourage you to pause your screen right here and maybe try out these 3. You could either try them all out and then check your answers all at once, or try them one by one and check your answers one by one. But get some practice in by yourself so that you're not just like seeing what I'm doing and not thinking through it yourself. On number 3, when it says x equals 5, remember I'm going to go over to where the x-axis is equal to 5. I'm going to graph that line straight up and down there. So there's my line x equals 5, a vertical line. Point C is right here. it looks like point C is only 1 unit away from my green dotted line, which means if it's 1 unit away on the left, it's gonna, when I reflect it, it's gonna be 1 unit away on the right. So I'm gonna graph that new point there on the right, and that's my C prime point. So notice sometimes I'm going from the left and reflecting it over to the right. Sometimes I'm going from the right and reflecting to the left, or up and down and up. You can reflect all over the place. That new point I wrote down was 6, 1. Again, pause if you need it to slow down. Number 4, the line y equals -3, I have graphed right here. Here's the point -3 for y, and then that line is just going straight through that point. We're trying to graph point D, which is right here. Notice the point D, if I'm kind of relating it back to this line, it looks like it's 1, 2 units away from the blue line, which means that I'm going to keep going in the opposite direction, 1, 2 units, and I'm going to want my point D to end up right about here. So there's my new point D, which I would call D prime. Okay, so see how it's kind of equidistant. Up here it's 2 units away, down here it's 2 units away. And notice how I'm really just ignoring all the other points on the graph. If this rule tells me to look at point D, I'm just looking at point D. I'm not going through and trying to deal with all the other points. So you could even go through and graph them one by one if you wanted. So the new point for that one was 2, -5. And number 5 asks us to go through x equals -5. So here's my line, x equals -5. We're trying to reflect point E, which is kind of interesting because point E is on the line. So if we want to make E equidistant from the line, it's actually 0 units away from the line here. It has no distance. And so when I reflect it, if I'm reflecting something that's on the line of reflection, it's just going to be in the exact same place, right? It doesn't actually move anywhere. It doesn't have space to go anywhere. So my E prime point is actually -5, -5, which is the exact same as my regular point E. Fun fact. So example 3 asks us to reflect, that capital R, reflect triangle QRS across the x-axis. So I wrote over here just some steps to kind of help and remind you. Step 1, let's always go through and sketch out the line. So my line is the x-axis, so I'm just going to highlight it. I'm not, we don't really need to like redraw it or anything. Just highlight over it, make it a little darker with your pencil or grab a highlighter. And then for step 2, now we're actually having to reflect 3 points at a time. So last time we were just taking 1. Now I'm going to take point R and say, okay, if I was going to fold this piece of paper, this would be kind of folding it up, right? I want to take RSQ or QRS and flip it up to the top. Doesn't matter which point you start with, by the way. I'm going to start with point R, and then it's going to flip. If it was 1 unit away from the line here, I'm going to flip it 1 unit up above the line, right? 1 unit below, 1 unit above. And then for point Q, it looks like Q is actually 1, 2, 3, 4, 5 units away, and S is 1, 2, 3. So S is going to be 3 units away in the opposite direction, 1, 2, 3. And then since Q was 5 units away, it's going to be 5 units above instead of 5 units below the line. Okay, so don't forget to label your points. So there's my Q prime up here, my S prime over here, and R prime, and then connect the dots. Please use a straight edge, make nice looking triangles. And then you can see, right, we have our pre-image down here. And remember I said yesterday, you might want to label them pre and image just to kind of remind yourself. We have our pre-image below, we reflected it or flipped it over that line to get our new image. And then it's triangle Q prime, R prime, S prime. All right, 2 more practice examples. I would encourage you to pause here if you haven't already, and just try out these problems before I show you. My cats are snuggling with me down here. So number 4 asks us to reflect across the y-axis. So always I'm going to start by drawing out that the y-axis down below. And now that I've drawn out that y-axis, I need to start reflecting some points. So it's interesting here because P and R, just like point E on our last 2 examples ago, P and R are on the line. So if I'm going to be flipping P and R over the line, there's no distance that they are to count out. It's just 0 points away. So P prime and R prime actually end up on top of the line there. And then Q prime, since Q is, let's see, 1, 2, 3, 4 to the right, Q prime is going to be 1, 2, 3, 4 in the opposite direction, right? So we're always thinking, how do these points relate kind of perpendicular to the line of reflection? So don't forget to label your points, P prime, R prime, and Q prime, and then connect your lines. And there we go. There's our new triangle reflected across the y-axis. Number 5, if you've tried this one, you might have noticed it's a little strange. So when I graph my line x equals -1, there we go, -1, and it goes straight up and down. I'm going to start with point K. So K reflects 1 unit across. So if K is 1 unit to the left, K prime is going to be 1 unit to the right. It looks like L prime is 2 units away from the line. So, or sorry, L is 2 units away. So L prime will be 2 units away as well in the opposite direction. M is 1, 2, 3 units away. So M prime will be 1, 2, 3 in the opposite direction. And then J gets a little bit interesting. So since J is on the right side of the line, 1 unit away to the right, that means I'm going to have to reflect it over to the left 1 unit. And then you can see that the shape starts to kind of overlap with each other. That's okay. So when I label my points and then connect them all together, if the line of symmetry goes through the original pre-image that you have there, most of the time it's going to end up flipping over itself or reflecting over itself a little bit and overlapping, and that is all right. So just be aware that that's okay. So your assignment today is page 557, number 7 through 17. I wrote in just cut some notes here to kind of help you out. Number 7 through 12 are not, it's not required to redraw the graph, but it can be helpful. Those are ones I think where you're just doing the point. And then on 13 through 17, where you're actually doing full reflections with shapes, please draw separate graphs for all 5 problems. So do draw the pre-image and then also draw the image. And remember yesterday I asked you to maybe highlight the image in a colored pencil or a highlighter or a pen or something. And that's all for today. So let me know, send me an email if you have any questions, and good luck on your homework.